Hello dear students, in chemistry I will definitely take a lecture for your doubts regarding to electrochemistry or electrolysis. But for that you have to solve all NCERT question, and if you have any doubts in NCERT question or calculation, you have to send me that topics or that number of questions like exercise 2.3.1, 2.1, whatever. Okay, and I am going to solve that question and I will take a specific video lecture for that doubt. Okay, but today we are going to we are going to learn a new topic, a new chapter which called complex compound. Now from today we are going to study about inorganic chemistry. Okay, this is very much important chapter, complex compound or coordination compound, complex compound or coordination compounds. Fine. Few basic terms like metal ion, ligand, etc. we are going to study today. Okay, you have to concentrate about that. But to study about coordination compound in organic chemistry, very much important chapter to gain marks in JEE or NEET. Sometimes NEET asks 3 to 4 questions from this chapter. Okay, 3 से 4 question आ जाते हैं. First of all, the first point is double salt. I am going to write two different definitions. If two salt get combined and maintains its original characteristics, then it called double salt. But whenever if we prepare an aqueous solution from double salt, then it will lose its character of double salt. Both definition is correct. Now, character of double salt. Now what we have to understand? First of all, like we have K2SO4. What we have? We have K2SO4. If we dissolve K2SO4 in water, we will gain K plus ion, which gives yellow PPT or yellow color with picric acid. With what? Picric acid. Then it is a characteristics of K2SO4. Why? It is because it gives K plus ion. Like it can also give SO4 minus 2 ion. It gives white PPTs or white color solution with BaCl2 or BaNO3 twice. With what? BaCl2 or BaNO3 twice. Like Al2SO4 3 times. Al2SO4 3 times. It dissolves in water and gives aluminium plus 3. Aluminium plus 3 gives white sticky PPT. Sticky. With NaOH. Why? Because it can dissolve in water and gives aluminium plus 3 ion. SO4 minus 2 will give white PPT with BaCl2 and BaNO3 twice. Okay. Now, K2SO4, a single salt. Al2SO4 thrice, a single salt. get combined with water and creates K2SO4.Al2SO4 thrice in 24H2. Okay, here two salts gets combined with each other. Okay, that's why it calls it calls what? Double salt. Whenever we dissolve this double salt in water, then this double salt will convert into K plus, aluminum plus 3 and SO4 minus 2. Now listen to me carefully. This one is a double salt, but whenever we dissolve in this double salt in a water, then it will gives K plus, Al plus and SO4 minus 2. It means they are not salty compounds, or they are not connected with each other, or they are not combined with each other. So whenever a salt get dissolved into water and lose its character, it's a double salt. But two different salt get combined with each other, but whenever they are individual salt, they can use K plus, SO4 minus 2, aluminum plus 3, SO4 minus 2. But if they are double salt, they can also use K plus, aluminum plus 3, SO4 minus 2. It means they maintain their original characteristics. Both definitions are correct. In short, अगर हमारे पास दो डिफरेंट सॉल्ट है, उस दोनों को कंबाइन करके अगर नया सॉल्ट बनाया जाता है तो उसको हम क्या बोलेंगे? डबल सॉल्ट. लेकिन अगर डबल सॉल्ट को पानी में डिसॉल्व करेंगे तो वो पूरा आयोनाइज हो जाएगा, पूरे आयन जो पहले मिलते थे वही मिलेंगे. यानी कि अगर वो इंडिविजुअल सॉल्ट जो आयन दे रहा था, वो डबल सॉल्ट भी वो आयन दे सकता है. क्लियर? तो उसको हम क्या बोलेंगे? डबल सॉल्ट बोलेंगे. इसका नाम क्या है? पोटाश एलम. We are using this alum for the purification of water. Now, what is I for alum? I means one-top factor, 2K plus, 2 aluminum plus 3 and 4 SO4 minus 2. It means total 8 ion can be produced from potassium. Now, another example of double salt, FeSO4 plus NH4 times SO4 plus 6H2O gives FeSO4 NH4 twice SO4 dot 6H2O. Mohr salt. What? Mohr salt. It can give Fe plus 2. This one can also SO4 minus 2. This one can also NH4 plus. This one can also. Total ion Fe plus 2, NH4 plus, total 2 ion and 2 ion SO4 minus 2. It means number of ion is 5. So I is also 5. It called ferrous ammonium sulfate. Fe plus 2 with ammonium hydroxide gives green color. Okay. NH4 plus with Nessler reagent gives red PPT. Okay, reddish PPT. Another example like KCl plus MgCl2 plus 6H2 gives KCl dot MgCl2 dot 6H2. In short, दो तीन जो सॉल्ट थे वो पहले अलग अलग रहते थे, अभी साथ में रहते, बस उतना ही है. तो उसको हम क्या बोलेंगे? डबल सॉल्ट बोलेंगे. This is an example of carnallite. This is an example of what? Carnallite. Carnallite is an example of क्या बोलेंगे उसको? और ऑफ मैग्नीशियम और पोटेशियम, यानी कि जिसमें से वो मेटल मिलती है. इसमें भी टोटल आयन कितने होंगे? 5, 1K plus, 1Mg plus 2, 3Cl minus. I is also 5. Wonderful. The whole thing is called double salt. But our chapter is not double salt. Our chapter is complex compound. Complex compound. Now, what is complex compound? Or complex salt, or coordinated salt. 2 or more than 2 salt get combined or reacted and creates or makes new compound and loses its original properties. डबल सॉल्ट में क्या था? दे मेंटेन देयर ओरिजिनल प्रॉपर्टी. कॉम्प्लेक्स सॉल्ट में क्या है? दे लूज देयर ओरिजिनल प्रॉपर्टी. ड्यूरिंग सॉल्वेशन और हाइड्रेशन they can maintain property of complex salt. They can maintain what? Property of complex salt. Let's see. Like यहाँ पे है FeCN twice plus 4 KCN. It can give Fe plus 2, Cn minus, K plus, Cn minus. But they are producing K4 FeCN6. K4 FeCN6. As you know, in solution, the ion from the bracket cannot be dissolved in water. इसमें से कितने आयन बनेंगे? Total ions are 4 plus 4K plus and FeCN6 minus 4. Now individual salt can use property of Fe plus 2, Cn minus, K plus, Cn minus. But this compound can use properties of K plus only, and another ion is FeCN6 minus 4. Two salt get combined and creates new compound and loses their original property. Original property में तो वो Fe2 plus Cn minus सभी आयन बना सकते थे, यहाँ पे वो नहीं बना सकते थे. लेकिन यहाँ पे जो ब्रैकेट था उसमें जो आयन था FeCN6, कॉम्प्लेक्स कंपाउंड में जो आयन था वो सॉल्वेशन में भी है या फिर हाइड्रेशन में भी प्रेजेंट है, या फिर जब हम उसका सॉल्यूशन बनाते हैं तब भी वो रहता है, तो उसको हम क्या बोलेंगे? दे कैन मेंटेन प्रॉपर्टी ऑफ कॉम्प्लेक्स सॉल्ट, दे आर कॉल्ड कॉम्प्लेक्स कंपाउंड. एज एन एग्जांपल, CuSO4 can give Cu2 plus and SO4 minus 2 plus 4 ammonia gives CuNH3 4 times and SO4. यहाँ पे आई कितना था? 5. यहाँ पे आई कितना आएगा? 2. Why? It can give only 2 ion plus 2 SO4 minus 2. This kind of salt नॉर्मली जो भी हम बड़े ब्रैकेट में जो भी लिखते हैं कंपाउंड, उसको हम कॉम्प्लेक्स कंपाउंड बोलते हैं. एक एग्जांपल शायद आपने ऐसा भी पढ़ा होगा सॉल्यूशन में, Cu2 FeCN6. दिस इज एन एग्जांपल ऑफ सेमी परमिएबल मेम्ब्रेन, बेस्ड सेमी परमिएबल मेम्ब्रेन, कॉपर हेक्सासाइनोफेरेट. क्लियर? नाउ टू अंडरस्टैंड कॉम्प्लेक्स कंपाउंड यू हैव टू अंडरस्टैंड फ्यू टर्म्स. जैसे जैसे हम आगे बढ़ते जाएंगे वैसे वैसे नए नए टर्म्स आते जाएंगे, हमको वो पढ़ना है. फर्स्ट ऑफ ऑल, ये जो है ब्रैकेट, इट कॉल्ड attractional sphere or attraction sphere. In attraction sphere, metal ion get combined with ligand with strong coordinated covalent bond. In an attractional sphere, metal ion get combined with ligand with strong coordinated covalent bond. वहाँ पे जो बॉन्डिंग होता है बहुत ही स्ट्रॉन्ग होगा. उसकी वजह से हमने क्या बोला था कि जो भी ब्रैकेट के अंदर जो भी एलिमेंट है वो लूज होते नहीं है या फिर वो आयोनाइज होते नहीं है. Why? They are strongly combined or they are strongly bonded with each other. Fine. Now we understand the first term, attraction sphere, but we get a new terms like metal ion and ligand. Now what is metal ion? मेटल आयन, इसका साइन हम रखेंगे M. नॉर्मली D block element which possess empty orbital and accept lone pair or electron pair from ligand, it called metal ion. A D block element which has empty orbital and gains electron pair from ligand is called metal ion or M. Fine. It accept electron pair, that's why metal ion is Lewis acid. Metal ion is what? Lewis acid. Now second term. Ligand, इसकी साइन हम रखेंगे L. A neutral molecule or negative ion which donates electron pair towards metal ion and makes coordinated covalent bond, then it should be ligand. Now it is not necessary it should be only negative ion or neutral compound or neutral molecule. Few examples like NO plus, NO2 plus, NH2, NH3 plus are the example of ligand which are positively charged. Okay, normally जो मेटल को इलेक्ट्रॉन पेयर देता है तो नॉर्मली क्या होगा, न्यूट्रल एटम होगा या फिर नेगेटिव आयन होगा. पॉजिटिव आयन आर आल्सो देयर बट नॉर्मली नेगेटिव आयन और न्यूट्रल एटम, देन इट शुड बी लिगैंड. लिगैंड इलेक्ट्रॉन पेयर डोनेट करता है, उसकी वजह से लिगैंड एक्ट एज अ लुईस बेस. एक्ट एज व्हाट? लुईस बेस. नाउ लिगैंड मेटल, it donates electron pairs towards metal, donate electron pair, that's why Lewis base. Accept electron pair, that's why Lewis acid. So the bond is coordinated covalent bond or coordinate sign or symbol. It is also called dative bond. It is also called dative bond. It is clear to you? Now three terms are clear. Which one? Attractional sphere, metal ion and ligand. Okay. Now we are going to see some examples. Like K4FeCN6, it should be your metal ion, your ligand, attractional sphere, बाहर है K प्लस कैटायन और पॉजिटिव आयन, यह पॉजिटिव आयन है, दैट्स वाई इट्स अ नेगेटिव आयन. और वही आपका क्या होगा, कॉम्प्लेक्स और कोऑर्डिनेटेड आयन. तो कॉम्प्लेक्स आयन यहाँ पे क्या है, नेगेटिव आयन. लेकिन अगर मैंने ऐसा एग्जांपल लिया हुआ है CONH3 6 टाइम्स Cl3, तो ये क्या है, ये है मेटल आयन, ये आपका क्या है, लिगेंड. ये क्या होगा, एट्रैक्शनल स्फीयर. ये आपका क्या है, नेगेटिव आयन या फिर एनायन. तो ये क्या होगा, कैटायन या फिर पॉजिटिव आयन. और वही आपका क्या होगा, कॉम्प्लेक्स आयन. कॉम्प्लेक्स आयन हम किसको बोलेंगे, जो ब्रैकेट में या फिर एट्रैक्शनल स्फीयर में. इट इज क्लियर टू यू? तो आगे हम नॉर्मली क्या लिखते हैं, पॉजिटिव आयन, पीछे हम क्या लिखते हैं, नेगेटिव आयन। क्लियर। कॉम्प्लेक्स आयन आपका पॉजिटिव आयन भी हो सकता है या फिर नेगेटिव आयन भी हो सकता है, डिपेंड्स ऑन दैट कॉम्प्लेक्स कंपाउंड। क्लियर। जैसे कि पहली एग्जांपल में क्या है, हमारा जो आयन है, सॉरी, पहली एग्जांपल में हमारा जो आयन है वो कैसा है, नेगेटिव आयन है, कॉम्प्लेक्स आयन नेगेटिव आयन है। लेकिन दूसरे एग्जांपल में कॉम्प्लेक्स आयन कैसा है, पॉजिटिव आयन है। इट इज क्लियर। ओके, बाद में फिर से सब कुछ हम पढ़ेंगे कि मेटल आयन क्या है इसके अलावा। नाउ द मोस्ट इंपॉर्टेंट थिंग टू स्टडी दिस चैप्टर इज लिगेंड। इज व्हाट, लिगेंड। A neutral molecule or negative ion which donates electron pair towards metal ion is called ligand। मैंने पहले भी बता दिया आपको कि सिर्फ न्यूट्रल हो या फिर नेगेटिव हो वो नेसेसरी नहीं है, पॉजिटिव भी हो सकता है। पॉजिटिव आयन भी लिगेंड की तरह बिहेव कर सकता है। ओके, कैसे बिहेव करेगा, लुईस बेस क्या बनाएगा, कोऑर्डिनेटेड कोवेलेंट बॉन्ड। फाइन, लेट्स सी क्लासिफिकेशन ऑफ। 2-3 लेक्चर हमारा सिर्फ बेस बनेगा चैप्टर का, उसके बाद में हम सब कुछ पढ़ना चालू करेंगे, लेकिन ये बेस आपको समझ में आएगा तो ही हम चैप्टर पढ़ पाएंगे। क्लासिफिकेशन ऑफ लिगेंड, पहले जब हम पढ़ेंगे दे आर क्लासिकल लिगेंड्स, देयर इज नो सच एनी एक्स्ट्रा method or information about ligand, simple ligand which donates electron pair. Okay, not more than that. Based on charge, first is positively charged ligand like NO plus, NO2 plus, NH3, NH2 plus, etc. are the example of positive charged ligand. Second example is negatively charged ligand like Cl minus, Cn minus, oxalate minus 2, I minus, ASO4 minus 3, SO4 minus 2, etc. which possess negative charge. Okay, and third one is neutral ligand. It does not possess any charge like H2O, ammonia, CO, CH3NH2, etc. are the example of neutral ligand. So we can classify ligands on the basis of their charge. The first one is positively charged ligand, second one is negatively charged ligand, and third one is neutral ligand. Okay. The another classification is based on denticity. Based on what? Denticity. New word for you. Denticity. Monodentate ligand. If you want to learn or understand whole concept of classification of ligand on the basis of denticity, you have to understand only monodentate ligand. Okay, which can donate only one electron pair. As an example, यहाँ पे मेटल, यहाँ पे एमोनिया है। एमोनिया में नाइट्रोजन के पास कितने इलेक्ट्रॉन पेयर है, एक ही है। एमोनिया कैन डोनेट ओनली वन इलेक्ट्रॉन पेयर, नॉट मोर देन दैट। ओके, जैसे कि यहाँ पे H2O है, H2O में ऑक्सीजन के पास कितने इलेक्ट्रॉन पेयर है, 2, बट ऑक्सीजन कैन डोनेट ओनली वन इलेक्ट्रॉन पेयर। ओके, जैसे कि यहाँ पे है CH3NH2, यहाँ पे नाइट्रोजन के पास एक ही इलेक्ट्रॉन पेयर है. It can donate only one electron pair. Which can donate only one electron pair. It called monodentate ligand. Okay, so it makes only one coordinated covalent sign or bond. इस साइन को हम क्या बोलेंगे? कोऑर्डिनेटेड कोवैलेंट साइन. ओके, तो एमोनिया ने कितने कोऑर्डिनेट बॉन्ड बनाए? एक. H2 एक, मिथाइलएमाइन एक. They are the example of monodentate ligand. They can donate only one electron pair. It can satisfy only one secondary valency of metal ion. A new terms for you. Secondary valency. Okay, to understand the chapter we have to study two main theory, a Werner's theory and crystal field theory. If you understand Werner's theory and crystal field theory, you can easily understand whole chapter. And we are going to study about what is primary valency and what is secondary valency and Werner's theory. But for you right now, in Werner's theory also, secondary valency is equal to number of coordinate bond. Then here, ammonia can prepare only one coordinate bond, so it can make only one secondary valency. H2 can make only one coordinate bond or dative bond. So like ammonia, Cl minus, F minus, H2O, CO, Cl minus, CH3NH2, etc. are the example of what? Monodentate ligand. Of what? Monodentate ligand. Why? Because it can only donate a single electron pair. Now what is bidentate or didentate? Bidentate और डाइडेंटेट लिखता नहीं हूँ मैं, डायरेक्ट हम समझते हैं. जैसे कि यहाँ पे मेटल आयन है CH3 CH2 NH2 NH2, a single compound. Here nitrogen can donate electron pair, here nitrogen can donate electron pair. If a single molecule which can donate two electron pair, which can donate what? Two electron pair, then it should be bidentate or didentate ligand. Bidentate or didentate ligand. It can make two coordinated covalent bond. देखिए यहाँ पे कंपाउंड एक ही है. कंपाउंड का नाम क्या है? इथेन 1,2 diamine, ethylene diamine. Short form is EN. A single molecule can prepare two coordinated covalent bond and it can satisfy two secondary valence. Secondary valence is the number of coordinated bond. यहाँ पे एक ही कंपाउंड ने कितने कोऑर्डिनेट बॉन्ड बनाए? दो. तो एक ही साथ उन्होंने कितनी सेकेंडरी वैलेंसी को सेटिस्फाई कर दिया? दो को. It is clear. So if you understand what is monodentate ligand, then you can easily understand bidentate. Okay. Another example is like यहाँ पे C डबल बॉन्ड हो, C डबल बॉन्ड हो, O माइनस O माइनस. This oxygen can donate electron pair. This one can also. A single compound C2O4 minus 2 or oxalate minus 2. It called oxalato ion. Oxalato ion. So it's a bidentate or didentate ligand. Another example. Like यहाँ पे मेटल आयन है CH2 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 NH2 NH2. This one. A single compound can donate two electron pair or can make two coordinated covalent bond or can satisfy two secondary valency, then it should be bidentate or didentate ligand. The example is propane 1,3 diamine. Propane 1,3 diamine. Clear? So, what is monodentate? What is bidentate? What is tridentate? Now tridentate. What is tridentate? Okay, which can donate 3 electron pair, 3 coordinated covalent bond, can satisfy 3 secondary valency like CH2, 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 sorry, CH, NH2, 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 metal ion. A single compound can donate 3 electron pair. Propane 1, 2, 3 triamine. Propane 1, 2, 3 triamine. Okay, like ASO4 minus 3, like PO4 minus 3, etc. are the example of trident. Okay, so if you understand what is monodentate ligand, then you can easily understand what is bidentate ligand, what is tridentate ligand. If a molecular ligand can donate more than 1 electron pair, it means bidentate, tridentate, whatever. It is polydentate ligand. It means bidentate is polydentate, tridentate is polydentate, tetradentate is polydentate. If a single ligand can donate more than 1 electron pair, then they are polydentate ligand. They are what? Polydentate ligand. I am going to show another example like pentadentate ligand. Definition लिखने की भी जरूरत नहीं है. Pentadentate ligand. Example is EDTA. ध्यान से समझना इसको. EDTA, ethylene diamine triacetate. CH2 CH2 and CH2 COOH, CH2 COOH, CH2 COOH and H. Sorry. And H. Ethylene diamine 1, 2, 3 triacetic acid. If it lose H plus, then it should be ethylene diamine triacetate. What is triacetate? Okay, here it can donate electron pair. It can also nitrogen, and this one oxygen. A single compound can donate 5 electron pairs. A single compound can donate 5 electron pair. That's why it's a pentadentate ligand. It is what? Pentadentate ligand. Okay. So it can make 5 coordinate bond. It can satisfy 5 secondary valency. Okay. Now same hexadentate. It is also EDTA. CH2, CH2 and CH2 COOH, CH2 COOH, CH2 COOH and CH2 COOH. Ethylene diamine 1, 2, 3, 4 tetraacetate. टेट्राएसिटिक एसिड. अगर यहाँ से अगर H प्लस निकल जाता है माइनस माइनस तो क्या हो जाएगा? टेट्राएसिटेट. It can donate electron pair. It can donate electron pair. This one can also. And 2 nitrogen. A single compound can donate 6 electron pair. A single compound can donate how many? 6 electron pair. That's why it's a hexadentate ligand. Ethylene diamine 1, 2, 3 for tetraacetate ion. Charge is -3, charge is -4. 5 electron pair, that's why pentadentate. 6 electron pair, that's why hexadentate. Now, there's a confusion. So how can we understand it's a triacetate or tetraacetate? If you understand what I am going to teach you in another lectures, then you can easily classify which one is pentadentate or which one is hexadentate. Normally we take only tetraacetic acid, a tetraacetate ion. It is clear? So it's a classification of ligand on the basis of denticity. Our first classification is based on what? A charge. And second classification is based on what? A denticity. Now third, ambidentate ligand. If any ligand has or possesses more than one electron donating or nucleophile center, then it could be ambidentate ligand. At single time and a single center, any individual atom can donate electron pair. If any ligand has more than one electron donating group, let's see how. Cn minus. Here in Cn minus, carbon also possesses electron pair and nitrogen also possesses electron pair. So carbon can also donate electron pair or nitrogen can also donate electron pair, or they are both nucleophile center. So that kind of ligand is called ambidentate ligand. But here at a single time, any single or individual atom can donate electron pair. It means if carbon is donating electron pair, then nitrogen cannot. If nitrogen can donating electron pair, then carbon cannot. Both cannot donate electron pairs. Okay, at a single time, any single individual atom can donate electron pair. If carbon donates electron pair, carbon get combined, it produces cyano. If nitrogen get combined, it produces isocyano. So they are ambidentate. Like CNO minus. If oxygen, then oxygen can combine. It called cyanato. If nitrogen gets attached with metal ion or get combined, NCO minus, isocyanato. Like SCN minus. Sulfur can donate electron pair. If sulfur get combined or get attached with metal ion, it called thiocyanato. It called what? Thiocyanato. And if nitrogen get attached with metal ion, it called isothiocyanato. They are names of what? Different ligand. We have name of every individual ligand. In further lectures, we are going to study about IUPAC nomenclature of coordination compound. In that lecture, I am going to teach you the different names of ligands. If you are here, okay. If a ligand, sorry, if any ligand has more than one electron donating or nucleophile center, then it should be ambidentate ligand. At single time, any single individual or individual atom can donate electron pair. Another example of or another classification of ligand is flexidentate ligand. Flexidentate, which are flexible. They can change their denticity as required. Like SO4 minus 2, it can act as a monodentate ligand if required. It can act as a didentate ligand or bidentate ligand if required. So it can change its denticity. They are flexible. Sometimes they are monodentate and sometimes they are bidentate. So a ligand which can flexible according to their denticity. Regarding to the denticity, they should be monodentate if required, they should be bidentate if required, then they are flexible ligand. Now there is another kind of classification of non-classical ligand, but it is a vast topic, that's why I am going to teach you in next lecture. But that is very important for AIMS and JEE examination. AIMS means NEET also, because they ask that kind of questions, so you have to understand that topic. Okay, if you have any kind of doubt regarding to this chapter, then I am going to help you. You can ask me personally. Okay, now the another thing is I taught you about electrolysis, but not a single student asked me a single question. Okay, so I'm not satisfied with that behavior, and I'm disappointed. So you have to learn whole exercise from electrochemistry chapter, and if you have any doubts in that chapter, then I'm going to teach you a different examples from our module, from previous year questions, from exercise, etc. But for that you have to work hard. If you give response for specific doubts or specific topics, then I can help. Okay, my dear students, just learn this topic, and if you have any doubts, then you can ask me. Okay, thank you so much.